Hello, everybody. Good night. And after finishing the book Geometry by Tatiana Alexeyevskaya, yeah, from the Gelfand series of mathematics, the book series, I decided to start reading Trigonometry in the same series by Israel Moisevich Gelfand, and and I I am studying the book and I found a problem that I would like to share some thoughts. And the problem says that you have isosceles is isosceles triangle, yeah, with an hypotenuse of 1 unit, you know, 1 unit. Sorry for my writing, and they want you since they want you to find they are asking to find this length, you know. And if you remember the some theory from geometry says that you can use the Pythagorean uh, theorem, which states that I will try to use my finger in this touch screen, you know, and let us see. It says that a square. Oh my god. This is the first time I am writing in the touch screens. A square plus b square equals c square. C square is the hypotenuse. And you probably know that from, no, it depends. I don't want to say that you probably know that because when some book assumes some knowledge on me, the reader, I have some circumstances that maybe I don't know what they are talking about. So, but now I am filling some gaps, and that's the reason I'm reading about mathematics again, because I want to uh, rediscover uh, this knowledge. So you have this theorem, and you want probably to apply it to this problem because they are giving you the 1 unit hypotenuse, this c squared, and you will come with some values over here to find this length. The problem is clear. Remember, this is an isosceles. I don't know if that's the right pronunciation. Isosceles triangle, the one with two lengths equals. So the approach that I've used is um, I'm going to erase this. I say to myself, well, these two, which I'm going to call A instead of X, uh, these two sides will be the same length, you know? And you need to find, they are asking for one of the lengths, but these are the same. If you find one, then you have the other one. So let's get started. But first, the approach that I used was what's the most basic uh, triangle that the authors used to explain this theorem, and I remember that was being the triangle with the length of 3, 4, and 5. And you start, hopefully you're seeing the screen. Uh, you apply the theorem of Pythagoras. You know, this is 9 plus 16 equals 25. 25 equals 25. You know, so this is the most you know basic triangle, basic units, basic numbers that satisfies this relationship. So once you know that, you can say to yourself, well, I want to use this approach and solve for this triangle over here with a, and 1. So again, I'm going to erase this. More cleaning, sorry. So now, using the same reasoning, you will have a, and 1, and you start applying the theorem. A squared plus a squared equals 1 squared. You know that is 1, but still you probably want to place it over there. And since one of the other books I didn't have over here is one of the other books in this series is algebra. Oh, here it is. Yeah, if this is like quite serious algebra, even if it is elementary, so I find myself uh, with one problem, like spending or investing 1 hour. So if you read your algebra in any book that you like, I happen to both that in the past, like 2 years ago, 3 years ago, 2 years ago, 3 years ago. Sorry about that. One silly thing. Okay, so you say, okay, we have 2a squared because you have a squared plus, you have a squared plus a squared. Look at this, 2 equals 1 square. Now you want to solve this equation. Okay, and I will erase this thing and start from here. Okay, so because I don't have too many space, too much space, sorry, in this setup. As you see, I'm using my hand. I will, okay. Hopefully in the future I will able to buy some fancy tools. Okay. 2a squared equals 1. Yeah, yeah. That was the equation. Now you want to solve for a because you want to know a. If you again remember your algebra, you can, of course, arrange the thing like this because this one was passed over here by subtracting one from both sides. I like to use this diagonal in the zeros because computer science by training, and in the past some professor I learned this from some professor right at the beginning of my career in order to avoid confusion with the letter O. So that's the way I do it. Okay, back to the problem. 2a squared minus 1 equals 0. Right, now again, how do you solve this equation? If you remember, you might find this, you will detect some familiarity with in this form from other studies that you might have, and is the difference of squares. Look at this, because remember this was one square, you know, but we know that it's just one, so just imagine there is a number 2 here. You can write it, and you have this pattern, and if you know by memory, or you can work it out, you will arrive to a, I'm not sure if you are able to see this. All right, this will be a squared minus ab plus ab minus b squared. This is, you want to use this pattern over here. Well, how can you do that? Since this is like kind of inconvenience over here, this number 2. But if you do it, if you apply it like this, as is, you will have at the end some minus a. But again, you can, I don't know if you have too much time to know. I don't want this video to be that long. Let's suppose you don't care about this and you apply the rule as it is. You will state something like 2a plus 1 times a minus 1. And as you can see, you will have 2a squared minus 2a plus a minus 1 squared. In that way, you will end with, I am forgetting this, sorry. 2 squared minus a minus 1, and you don't want that. You want this. You want to be able to go back to this form, so that's not the way to go. What can you do? I'm erasing this with the mouse. Okay, so you can use some trick with this number and say, well, actually 2 is, I'm going to erase this and rewrite this over here. Oh, that's all. Okay. So I think we should rewrite it then, because okay. Sorry about that. I didn't knew that this have some you should be aware of that. You can say, well, this number 2 actually, in fact, is, look at this, the square root of 2, you know, to the square number. And as you know from algebra, this will end being 2, you know. And now you can apply the theorem that you know, the rule, the difference of the squares. So I will write, and now if I will able to, okay, 2 I have that ended being like a 6. Okay, so now this is 2 actually, right? You have the square root and the square power. So it haven't changed at all. It hasn't changed at all. And now you can apply the square rule, and you will say something like square root of 2 times a plus 1 the square root of 2 times a minus 1 equals 0. If you do the math over here, this will be this number, a squared, and this will cancel out, minus the square root of a plus the square root of a minus 1. So this is the solution for this equation over here. And now how can you you know, find actually the value of a? You will start from establishing one of these as 0. I will choose this because let us see, that will be square root of 2 times a. Okay, I'm going to establish this as 0, so I am working only with this. But at the same time, since we are running out of space, I'm going to directly put this number 1 over here, equals 1, and all of these will take us to, I'm going to write this arrow. This number 1 seems like an arrow too, sorry. So again, you will put this square root of 2 over, we'll divide both sides by the square root of 2. And this is the solution. Okay. 1 over the square root of 2 is a solution. But how can you be sure about that? You know that this number is, you know, like, you can't represent this number with any integer. So since I am a software developer, And I wanted to see that this is actually 1, that this actually satisfies the relationship uh, a squared plus b squared equals c squared. I have over here this instance of Debian, and I have this Scala, and I will compute. Well, the computer will do it. I will express this computation, the square root of 2. And look at this. This is the answer. You can reuse this variable over here. Res 0. Okay. Now we are reusing this. And you have, let me try to, this this expression is 1 over the square root of 2. Look at this, 1 over the square root of 2. Now this is a. This is a. But in here we are not using any variable, but we are using the one that the Scala provides, raise 0. So this is a. Imagine this is a. So a squared, a times a squared equals this. But this is an isosceles triangle. So let's add this again, plus 1 plus 1, and you have this number, which is not 1. And you can say, well, if you know some of the fields of mathematics, you can say, in practice, it is 1. You can say that. You can go to any other programming language, Python, for example, and do the same. Let us see if we can do this over here. It's not defined, but we imported math. Okay, and as you can see, we will end to the same result. It is varying a little bit. Let's call it a. Okay, a square, a prime. Let us see. And you will you might know where this thing is going. Again, same result. And here's exit. And then you can go to the internet, and there is some, this programming, this computer, this programming language, Octave, and we have found this online stuff over here, interpreter, without installing Octave. And I'm not sure if you can see this, but we will do the same. Let's go to, look at this, ANS, this is the A, and now you have this 0.5, okay? And now you have your 1. Now you can see that 1 over the square root of 2 is the answer. And you can see this because these computer programming languages are designed for exactly this kind of computations. There's another one called Julia, but I didn't install it. Probably I will do it. If you know that that's the case, that it gives you one, well, it will be great if you can put it in the comments. Otherwise, I will investigate on my own, spend some time. And back to our problem, why I did this, uh, because I I want I want to share that if you can afford the time, you can certainly, and if you are lacking confidence, especially for the people lacking confidence, like me, or my entire life, with some fields of study like mathematics, you can certainly do it. Take my word for it. Uh, I will yet another training course uh, on geometry. I will try to come up with some videos and also uh, some kind of question that people ask, what's mathematics for? In here you can see that it is a tool that helps you to exercise some reasonings, and this kind of mental exercises helps you in your daily life. And that's what Israel Gelfand is saying in these books, that the thing that you can achieve or attain or achieve, yeah, with mathematics is to attain a higher level of intellectual uh, in your brain. But other than that, is as you saw in while solving this problem, everyone can do it. You just need to put the time, and it's all about remember some stuff, applying some rules, and when the thing becomes mechanic, be aware of that because the thing you want to do is reasoning, um, applying ideas instead of mechanically uh, doing things. You know, I don't know how much time this has been. Thank you very much for watching the video, and let's hope I come up with those videos on geometry very quickly. Thank you very much and have a good night. See you later. Bye.